Okay, right, so let's start. And we'll start with simply sampling. What I've got here is at the top of the screen, the sampling toolbar. So these are a number of configurations that I've loaded via a right click and sample bar list. And I've activated the sample bar itself by clicking here. So if I click on sampling, we go straight into a window for spike discrimination. We'll go straight past that. The screen will be populated in a second after we've admitted the Delsys system. There we go. Delsys is ready, so we continue. On the left here, we have the main data view with many channels in it. Above that, we have a triggered view. Over on the right, power spectra. Underneath that, an interval histogram. And below that, an XY plot, which will represent eye movement in. Okay, so I'm going to press start and look what happens. On the bottom view, you can see the x-axis scrolling, yet nothing is happening. We have not triggered this data capture. And that's because I'd switched on the triggered mode within this dialog, and you can see that trigger is flashing here. This is the one and only time that we use the trigger input in the front panel. Now, if I bring in some video as well, so I'm recording this through the S2 video program. I'll take a camera like so. Okay, and I'm going to start pointing that at the front panel here. And you can see the trigger input is active here. And I've got connected to it a box which allows me to produce X and Y values through this joystick, as well as a push to enter, and that should produce an event signal for us. If I press it now, there we go. Data is now scrolling across the screen. We'll move the video out of the way for a second and bring up this view, stretching it out to show you what's inside it. So at the top here, we've got digital markers. Now there's nothing in it yet, likewise the keyboard channel. But I have a box which I'm going to use to produce digital markers as if a separate computer were delivering codes to us. The keyboard channel though, if I type in hello, there we go. Simple annotation of your data. Underneath that though, the text mark channel is reading from an external source. So this is some garbage data that I've heard, and I'm spitting out through a small device, and I'm reading it in through one of the COM ports, and automatically the text marks are being produced looking like this, containing a little bit of data in each. Now, as these are automatically produced by the program, we could then get, say, a script to investigate the data or accept the data of each text mark, break it down, and perhaps produce new waveforms from them. Now, interestingly, in the new feature, these text marks, you see red, blue here, and the blue here, are produced by a script working online. Now, I'll go into more detail about that new feature, but fundamentally, it's a triggered script. That is, you might ask the script to run at sample start, at sample end, or at some time point or points throughout the recording. Okay, so what else have we got? I've gone through and I've looked at an X position channel, a Y position channel, and the two of those, if I move the joystick I mentioned and optimize the screen, you should see, if I optimize again, yes, X and Y. So here at the bottom of the screen, using Control Shift and a drag there, you can see the X and Y positions. Now notice that the second of the two channels here we see it in gray, and that's because it's not being recorded to disk, because I've also set this data acquisition into a triggered mode. So only when we receive a trigger through the event inputs will we record a second or so around that trigger, the trigger being this channel here. Let me just highlight that by bringing it down. There we go. It's a dirty switch, so I'm getting more than one trigger there, but that will act as a recording point around which we will capture a waveform section. And notice how we've changed to green in this case. Okay, Control Z just to undo what we've done there. I'll move back out and we'll look at a few more channels here. Next is channel 3. If we look at that, this is the play wave. So on the toolbar section here, I have no output, EMG, and blood pressure. If I click EMG and now optimize, this is a pre-recorded file held in memory inside of the 1401, which I'm playing out. So we could use this as a stimulus, for example, so it could be sound. In my case, I'm going to use this or a blood pressure channel to help us do some online analysis. Okay, so that's the play wave. Above that, channel 4 here, Control Q. This is the sequencer output. As you can see, I've got a changing amplitude square wave, which once it's got to a fixed level, a level that I've set, then we go straight into a sine and then a number of square waves, and that'll repeat 10 times before switching off. If I drag to the end here and just zoom out a little, there we go. Now, to switch on these outputs, I'm using the sequencer toolbar. I've used H for halt, A to start the A section, which is a ramp. This ramp repeats, but I've thrown in a random time between the ramps. So you'll find that some are closer to each other than others. Once this is repeated, it'll go on to B. Once that is repeated 10 times, on to C, etc. I'll stop that output. Okay. So we're on channel, channel 5 now, yes. Nothing happening at this point. That's because this is a wavemark channel. And if I go to the edit wavemark function, I can now start updating my incoming spikes. Once I do that, producing the templates here, then my interval histogram now has data to process. Okay, right, sorry. The question, can the synchronized video recording S2 video also be controlled by a trigger? Preferably, yes, is the answer. We would prefer a camera which had a TTL input. We could then provide, say, 25 or 30 triggers a second. At each trigger, the camera would take an image, and that makes the recording timing much, much better than a freewheeling, say, webcam. Now, the camera I've got here is used in some Songbird work, and we bought one to test out. It's pretty good. It's offering, let's have a look. The camera is currently running at 25 frames a second, and you can see it here, camera rate. Now that dropped a little bit because I think I moved the camera a bit too fast, and we're getting a drift of about a millisecond. This has some onboard compression, MPEG compression. So it saves us a little more effort hardware-wise at the computer. Okay, right. So, right, yes. So yes, the camera, the video can also be triggered just as we do with the data capture here. So a waveform being captured on a trigger, we could also tell the video recording to start and record during that same period. So yes, I hope that's answered your question. Right. Okay, so the wavemark data. I won't go into detail really here, but what we're looking at is an output from a mini disc player, real recordings. It's a lot smoother than it really should be. But there's a spike coming in. We can produce more templates from it. Let's just get rid of these and allow it to create more. Perhaps updating our window position like so. And you'll see, once templates have started to be formed, this is a little odd that it's not doing that, channel 5. We're going by shape, online update. No templates results in the wave marks coming in as unclassified. Okay, if we allow make templates and we modify, yes, that should be quite reasonable. Okay. We modify the template window, that is the area of the spike which will be templated. We should start forming templates like so. And online update, and you'll see a color change in the channel here. Okay, so we've got a couple of these wavemark channels, and they're here and channel number 12. I'll group all these later. At the same time, I have channel 11, which is the raw continuous waveform, and that's separated out through one single port into this continuous waveform and to the wave marks. Okay, I'm just going to stop there for a second. Okay, I'll come back to the video triggering in just a few moments, if that's all right. Right, okay, another quick question though. We had a question, is there a way to quantify the detected spikes online, e.g. Getting their event rate in a particular wavemark channel? Okay, well, we have our single wavemark channel. Remember, we've got a couple in the data file, and I haven't set that other one up yet. We want to get a rate display. So what I'm going to do is I can change to channel draw mode here, but I'd prefer, I think, to go to duplicate channel. And in this duplicate, I can say channel draw mode and a rate display raw. Now if I optimize this, there's our rate, and it seems as though we're not triggering here. Okay, so let's go back to our channel 5. Where is it? Channel 5 and the rate display. It's because of this width. There we go. So you can see the rate histogram building there. 5A. There we go. 1 second. Raw and optimize. Okay, so 2 rate displays. If now I exclude, using the marker filter, all codes except for the dark blue 01 code, I'll invert the marker filter, hiding everything away apart from 01, and update. You see how the rate display drops because there's far less spikes to calculate, to count. Okay, so hopefully that answers your question on a rate type of display. Now, if we go back to channel 5 and put this back to waveform, not its original form, the wave mark, but waveform, we see all of the codes. If we change to instantaneous frequency, I'll put the dot size up. There we go. Now we're seeing a instantaneous frequency. These are dots representing the one over the interval between spikes. So we can see firing activity that way. Okay. Right, I think I really chose the wrong channel here because this is switching between recorded and non-recorded mode. Right, so let's go back, show hide channels, show all, and draw. So instantaneous frequency, rate display, the original waveform, and then I'm looking at channels here, EMG, and I'm looking at accelerometer. There's several of those channels. I'm going to break those out. I'm going to do what I did for the triggered display in the background, and that is I'm going to window duplicate the display, and I'm going to switch off all channels except those coming in from 6, 7, 8, and 9. I think that's it. Oh no, I've got 13, 14, and 15 as well. Draw. Now these channels come from this device here. Okay, so that's a Delsys Trinio sensor. There's pickups for EMG on the front here. There's gyroscopes and accelerometers inside. If I optimize here and I shake this around, you can see the signals produced. Cyclic there. I'll move over to the right here, shaking it again. Okay. An EMG at the bottom of that channel. So not very convincing there, but I'll find a muscle in a minute. But, anyway, it's loose, it's not stuck down at all, but you can see EMG on that channel 6 at the bottom of the window. I'll open that up a little more now. Okay, so how did we get that? Well, it's not coming in through the 1401 at all. I'm using a Delsys Trinio base station and a couple of sensors. If I open up this video recording again, you'll see the base station that I'm using. So this is a wireless unit, and there are two sensors in the sockets at the moment. This unit is triggered to start sending data through this trigger line here. Okay, I think hopefully you can see the label there. Data is transferred through USB all the way through to the computer here. Okay. Now, our method of getting the data through is through what we call a talker. And here it is, just a small piece of software that handles the communication between Spike2 and the Delsys software. We open that up. Here we have the Delsys control utility. So in this case, I've added just one sensor, but there could be multiple sensors, meaning you could have, for example, 16 EMG channels plus 16 channels of accelerometer, sorry, 3 times that number, accelerometer and gyroscopes, given the same type of sensor here. There are a range of other sensors, simple EMG, one channel of EMG, through to the Avanti type now, which have more capability. Okay, I've been asked to go back to the chat. Okay, we will. Right, can we somehow threshold those spike rates to trigger stimulation? Okay, we will do that in just a short time. And I did not watch from the beginning how to take the video capture. We haven't gone to starting the video capture yet, but we will in a few moments. Okay, so finishing off with the talker. Delsys, DSI, Intan, GTEC, we have talkers for. Some have to use the producers, the manufacturers' software, like Delsys here, so we can get a pipe through to their hardware. But once we've got this pipe working, once we've got a communication pipe, then we can go to our sampling configuration, and channels from the talkers will be available. As you can see here, we have real waves, and the source is the Delsys talker. Now, it's possible to have multiple talkers running at the same time. So if we wanted to run DSI and Delsys and Intan together, and in fact GTEC, we could. Right, we'll just close that up. So the concept of talkers, the ability to record from a third-party device through software, ultimately through a USB cable into Spike2 here. And that can be with or without a 1401. Right. Let's look at some other channels here. In fact, we'll throw that away. Okay, so we've got our continuous recording area, and we've got a window here which is showing us some triggered data. So if I now produce a blood pressure trace coming out of DAC 0, DAC 1 even, and being fed back into the ADCs, if I now produce a trigger, we now get a sweep of data across the screen. Now, as you can see, as a simple switch, let's put the camera back in place. I need 3 hands here, really. I'll go over here. So I'm just using a simple trigger like so, push switch, and that produces a switch closure, shorting the input, and that's how I get my trigger. Now, it must be said that the trigger is dirty. So there's the 0 mark. That's where my triggers normally exist. But as you've got 2 pieces of metal sliding across each other on the switch closure, we're getting these events due to the lack of debounce. So these, yes, should be taken out. And I'll show you exactly how to do that in a short while. Okay. Right. We have a question. Is there a benefit to using a talker rather than plugging in Delsys outputs to the 1401? From my point of view, no, because I would like you to have lots of top boxes or synchronized units to be able to cope with all of the channels that you want to sample. But going through the talker through USB, we save that hardware, well, we get around that hardware restriction. We're doing this free of charge, as it were, through the USB port. The Delsys equipment, they may correct me, but I believe there's a delay of some 92 milliseconds, I think, for EMG, and some 48 milliseconds for accelerometer data. So if we were to produce a trigger at the sensor on the body, it would arrive some 92 milliseconds later at the analog outputs or through the talker system. Now, the talker system takes care of that offset. We don't do that through the analog side. We'd have to apply a channel shift or offset. So if we took a channel like this now, and if I duplicated it, duplicate channel, now if I set channel process and I said time shift, add, let's make it a little bigger, let's make it 5 seconds. Okay, now you can see these 2 channels are different because one is offset by positive 5 seconds. Okay, so we can apply the same technology to adjust negative time, the Delsys signals coming in. Now, the final reason for not using the Delsys talker is if we need to react to the incoming signal in a very fast manner. And we can only really do that if we feed signals, analog signals, into the 1401, where we can access the data with the sequencer, onboard sequencer. Okay, just getting on to a couple of other questions here. Right. So yes, the analog signals have a delay, and there are fewer analog outputs in available data channels. Okay, so there's actually, I believe, 64 available outputs on the Trinio box. Okay, and Stephen there is adjusting, correcting me on the delays there, I think. So, all right, so it's pros and cons for the talkers. If we looked at the Intan system, for example, we could take, say, multiple 64-channel head stages, so there's small chips on a circuit board, and record those all through USB 3 and the talker to Spike2. So we've got multiples of 64 channels. Now, it'd be fairly costly to do the same with 1401s. It could be done, but it would be costly. So for streaming data, large amounts of data like that, 64 channels of spikes, multiples of 64 channels of spikes, the Intan, the talker seems to be the way to go. Now, thinking about multiple 1401s, perhaps synchronizing units, if we took the power that I have here on the bench and the one that we're using to record and wanted to connect it with a micro device like this, then we would want to get synchronization between the two. And if you can see clearly, I'll put the left to right here, the synchronizing port here would need to be connected through a cable like so. So this is a 3-headed cable, this single end, the master, through to multiple 1401s on these two ends. That provides a common clock to all devices, and using the triggered start, we can have all of the devices start at the same time. They're then timed to a single clock source. Okay. Right. Okay, so let's carry on with where we were, the triggered display. Now I'll set this up a little better in a moment. So we've got something, a waveform that we're triggering on, rather than this fairly random positioning that I'm providing. Okay. So if we step back from this, I'll delete channel, go back, and there we go, back to our source data. Now remember, I'd set time of day as the x-axis. If I double click and go back to seconds just for ease, there we go. Right. While we're there, let's just have a quick look at trigger overdraw again. Now, for those people looking at ECG and sometimes EEG, they might want to have a paged triggered display. So there's no physical trigger, there's no keyboard or event input that triggers the display to update. If I enable this and then apply, I can set a width of, say, 5 seconds, draw, and close. So now here are the pages of our chart recorder running to the end and then quickly refreshing to update with new data. Okay, so that's page display. Imagine an ECG machine. Okay, so let's switch off the trigger. We'll go back to normal. Using control and drag on the x-axis, we can view the data as we're dragging to see what the result will be. Okay, the XY plot on next. Here we have our two channels, X and Y, in our data view. Let's just open this up a little bit. One is recorded, one is not. So here we go. X and Y, some sort of random movement of the joystick, and we're seeing the head of this snake move around. Now we could have this made up of two channels. One as a single data point, which really does represent the head, and then this tail-like structure that you can see here. Now very quickly, to show you how I set that up, I'll go to Process Settings, and here you can see that I've asked for an X measurement of value at point at cursor 0 from channel 1. And I've done exactly the same for channel 2 on the y-axis. Now, critically, at the bottom here, I've set a limit to the number of data points I can accept. So as soon as I've filled up 100 data points, I've got real values, 100 real values, then I start throwing away the oldest. Okay, so that is how I formed this snake-like display. Now, with a script or perhaps a little bit of careful adjustment, I could put in other items like targets, for example. I could draw a rectangle, which would be the position to which I would like the eye to go. We often use this as force feedback. So instead of any x-axis, we simply have something that moves up and down or left to right. Okay, just sitting on 0. So that gives you some sort of idea. So force feedback. A script monitoring this could then change the screen color, for example, between green and red to say whether the subject was on target, 80% of NVC, a sort of idea. Okay, so that's the XY plot. Along those lines, well, continuing on that, I must say, the process setting, I stepped away from that a little too quickly. X against Y, channel 1 against channel 2. But how do we find the data? That's where cursor 0 comes in. I've asked for cursor 0 to find data points, all the data points in this case, on channel 1. So it's stepping forward. Every time it steps, it finds a new data point. Then it triggers the process to take the data, take the measurements, and put it into the XY view. So what I'm going to do now is get rid of that just to keep things clean. And we might now use the same cursor, cursor 0, as a means of triggering, say, from the rate display. So let's open up the channels again. Okay, so we're going to go for channel 12 here. I'm going to switch off the markers that we see across the screen. View, vertical marker. This is how we produce them, and this is how we can get rid of them. So vertical marker channel 30A, I'm going to say no channel, and they disappear. Edit wave mark. I'm going to have to reset my recording so we can start seeing data coming in. So there's our spikes. Okay, and optimize. So we've done a basic threshold. We found spikes, and we're getting some classification here. The black are untemplated, the blue have a marker code 01. Now I haven't added any more in yet. There are other spikes, but let's continue from where we are now. Right, I've just had a very quick question, which is, can you insert an image into an XY plot that can be traced with a snake of data points? Well, as with any of these windows, we could add a background image or channel image. So if I fill the rectangle and I browse to find a test card, for example, fill rectangle, fill background would be better. And that should be right. I think we're not going to get it on that channel. Let's go to channel 1. Fill background. So just show channel 1. Cool. Okay. That background channel image should be popping up. I'm not sure why it's not. Fill background. Let's fill rectangle from left 1550 to right 1950. I think it's probably the wrong size here, and 2.5 to -1.0. Okay, browse. Maybe I just didn't pick up. Okay, close. Right. I'll have to check that. Now, remember, we're doing all this live, so I haven't had too much time to think about it, but I should be able to add that image there. To answer your question more fully, background images for an XY view, a resource, a result view, or a data view, yes, they can be placed there, but we have no idea of, well, we have less idea about the scaling, okay? So perhaps it's better to draw your shape as another channel, multiple channels in the XY view, and then use the measured channel to be able to trace around it, okay? I can show you something like that in a short while. I hope that answers your question, at least in brief. Okay, right, we have then channel draw mode, and we're going to a rate display, and we'll set this to say 5 seconds. Let's go to 1 second draw. Right, I could probably do this with volume, so I'm going to change the volume up and down so that I increase and decrease the number of spikes. If I set cursor 0 on the screen, previously I'd set it to get to the latest data point in channel 1, and then I'd hidden cursor 0, hide the cursor. This time I want to go active mode, and I want to tell it to find a rising threshold on channel 12, the current channel, when the threshold reaches, say, 50 spikes per second. Say OK. Now, it's not going to do anything until I ask it to move using Control Shift and the right arrow. It hasn't found anything yet. Or by telling it to process to an XY view, or in our case, a data channel. So 50, hysteresis, delay. So X measurement is cursor 0. And we're going to set to event, go new. And we're now going to process as quickly as we can all data. And there's no leeway for processing. Okay, so I think that maybe this would work perfectly fine offline. I think we're not going to quite get this with the recording I have. Come on. Okay, so we should be seeing this cursor 0, active mode, rising threshold, threshold level, noise reduction, delay after crossing. There we go. Right. So what I'd set was a delay after crossing, meaning that we must stay above that level for at least that 1 second. Now I've set it to an instantaneous detection. So as soon as we hit 50, bang, go there. Now it's leaving behind these markers. And those markers could be used as a label, a flag, to initiate some triggering of the sequencer, for example. Another way to do this rate type detection is again to move it back to the 1401, which would be much faster and more accurate. And that would mean that we would keep a count of the number of spikes over a set number of ticks, the ticks representing the number of seconds that you want to process. And when we can count the number of spikes as being 50 or above, then we would stimulate and then have a delay until we start looking again. So I hope that's answered your question about using a rate display or rate as a trigger for stimulus output. Right. I think let's get out of this channel. Channels, show, draw. Okay, very quickly before we go and dissect how we actually got to all of this, we'll look at the text marks. So they're the guys at the top of the screen here. So these are the ones that are produced by a script that's running every 20 seconds, triggered to run every 20 seconds. In fact, I should say executed and then halted every 20 seconds. So it's not running all of the time. It's putting in a little note of the time that it executed at. And below that, these are the text marks containing garbage data, as I mentioned in the first thing this session. These contain garbage data and are coming automatically, being produced automatically through a serial line input. Now, what I wanted to show you is, of course, the keyboard markers that we've mentioned before. They're appearing here. Let's zoom out a little. Okay. As an annotation, they're horrible. Single markers, yes. But if we try to type something, you can see I've got my spelling wrong, and it's very difficult to see anyway. So that's why I would prefer to use a text mark channel. Now, moving on to the digital markers. So using my camera again, bring this across, so this wide, right. So we have the Trino, we have the 1401. Into the back of the 1401, I've plugged this device. Now this is just something to help me test various things. So I have some event inputs here. So the 8 dedicated event lines of the 1401 could be polled. And I have the ability to set codes. So these light up and go dark, depending on their switch position. If I then send, you should see behind this window, actually, these markers. So that's the code that I've developed. So switching off now and send EA. One of those is probably broken, and 00 marker. Okay, so extra codes that could be recorded through the digital inputs of the 41 alongside the triggers that we've been looking at. These events that we see here. Okay. Right, so that's some digital markers, the keyboard text mark. There are other channels that I've also incorporated here. We have, I think, this one here, channel 16. Okay, that's Spike Waveform, that's the wrong one. So I'm looking through, changing the channel number, play wave sequencer, wave marks, another wave mark, Spike Waveform, EMG, accelerometer, etc. And it looks as though I've actually failed to store a derived channel, which is a bit of a pity. So I'll go and produce that again in a second. That will be based on channel 11 here. Let's treat channel 11 for the moment as EMG, so that we could then duplicate that channel and start applying some processes to it. So channel process, we have, say, DC remove if necessary, a rectify, and a smooth. And if I increase the smoothing factor, those, you can see we're getting some bursting, as it were. And this is only spiking data, of course, but there we have EMG-like rectify and smooth. Now, as a waveform, this data could be accessed using cursor 0. Cursor 0 could find thresholds on this rectified and smooth data. There's only one cursor 0, and there's only another 9 vertical cursors that can be used per this view. So we would duplicate this view where we get another 10 cursors, 0 included. Right, let's stop the recording and let's go and see how this data was produced originally. I'm going to take a gamble here and just save this data to desktop, and let's go into training here. Let's call it test. Okay. Right, now the reason I say gamble is it's a brand new video camera that I'm trying, and I want to make sure that its onboard compression is going to work and save correctly. And I'll only know that once I've saved the file here, and then I can go to multimedia files. And here you'll see the whole recording, time locked to cursor 0. There we go. So if I move this around, little activity, hopefully we'll get different images in a while. Huh. Okay, must be choosing the wrong area. But this now will be a video and possibly an audio recording of everything we've done before. Okay, so very quickly, how do we get to the video in the first place? We should call up the S2 video recorder. Now that, it appears, gives us a choice of the video device and audio device to use. We could then make some configuration changes. We can allow for on-the-fly compression. This particular camera, as I mentioned, does have an MPEG compression, so I'm not going to do any further compression here, but we would highly recommend the XVID MPEG compressor. Same again for audio, and whether we're using the AVI format or, if unselected, we're using the MP4, which is again a preference. There's timing information with an MP4, which is somewhat lost with the AVI file format. Anyway, if your camera, your signal source, microphone or camera, is direct show compliant, it should show up in the list here. Now, there is a mode for setting the slow frame rate, so we can't actually pause the video recording, but we can make it slow down. So 1 frame every 2,000 frames, effectively pause. So 1 frame per 2,000 is captured. So there is no concept of no images in a video recording like this. The last frame will just continue on during that supposed pause period until we pick up the recording at a faster rate again. Right, tidy up. And let's look and see what we did here in the sampling configuration. So stretchable window. So I've asked for 1401 base channels here, 41, 41, 41, 41. Then we have the Delsys talker, a few more 41 channels, Delsys again, and then a derived channel. This is the filtered waveform. I'm afraid that was there, I failed to spot it. Followed by text marks and markers. Okay, so what's a derived channel? Well, a derived channel is one that uses a source, whether that be a talker or a 41 waveform channel, to which I can apply filtering, rectifier, difference, or downsampling, or a combination of these. So we'd add these from the list, a little like the channel process that you saw earlier. So we rectify and then smooth. So we're picking up the source channel as channel 11 here, but as you can see, it could have been one of the talker channels. So I apologize, I didn't show you that more clearly earlier. I'm afraid I didn't spot it. So if we choose an IIR filter, we could then design the shape, that is low pass, high pass, band stop, etc. Apply that, and that process will be used with the derived channel and stored to disk, unlike one of the duplicates that we produced earlier, which is simply a duplicate. It's held within the resource information associated with the data file. Okay, so waveforms from the 1401, the Delsys channels or talker channels. If I double click here, we have a list of channels available, and we can use part of the Delsys software to configure and set a triggered start, for example, and the time of that trigger. Now, this is quite important, or very important, for many of the talkers. We would like to trigger the start of the data stream coming through so that we know when it starts, and then we can keep correcting the drift between the two clocks of the talker device and the 1401. So I set this to 50 milliseconds triggered start, and because I did that, within the sequencer and the graphical editor, I used the initial section, which runs as soon as we start sampling, to then produce a pulse out on digital one at 50 milliseconds. So that's my Delsys go signal. Right, other things here, waveforms, event channels. This we use just to log the trigger button I was using earlier. If we edit this, you can see that we can choose between event plus, event minus, and level. So these are the edges of a TTL pulse. So positive edge, negative edge, or both. So we get duration as well. Now, sticking with event plus, I could have added a debounce. If I'd set that to say 100 milliseconds, that would have eliminated all of the extra triggers after the first for 100 milliseconds. Would have made my switch rather clean. Okay. Now, with any of these channels, waveforms and events, etc., we can choose which port they are accepted from on the 1401. Right, I will come back to this, but I've been drawn to the chat again. Xavier, can we use negative delays with trigger to record from a point in time before it was detected to happen? Yes, we're heading that way. I'm going to go to a very important place first, and that is resolution. Okay, here we should always check that the sample rates that we have asked for are actually given to us, or something very close, oversample preferably, are given to us here. And the best thing to do is select the correct type of 1401 that you have, and at least hit suggest, which will then recalculate two values here, the microseconds per time unit and time units per ADC. That will give us an ADC rate into which will be divided, or the channels that you're sampling. You see here, I've asked for 30 kilohertz, but I've actually got a little over at 30.3, sorry, 30,030 hertz. Very important. It's so easy to create a new channel from here, waveform, and we say, let's go for 12 kilohertz. Okay. And you'll see it's gone down to 10,000. Now that's quite a significant difference. Into resolution, there's our 10,000. If I suggest, it's actually pushed it right up again. Okay, so I think it was this channel here, so it's got it much closer. Now we can do more with extra channels, etc., to try and balance this out, and not choosing figures like 30,000 in this case, which is a bad divisor for us. There is burst sampling, which will improve things for a large number of channels at high sample rates. This means that instead of channels sampled in order, loosely speaking, we burst through those channels as quickly as we can and then place their data points down in time. Now, the problem there is that where we could normally tell you where every data point, which channel would have been sampled at a given time point, I can't see it now. I did have a diagram of it. With burst mode, we can say that the first channel was sampled at this time, but we cannot tell you precisely where in this interval, microseconds per time unit, where the other channels were sampled. Okay, so most of the time, as you can see, 2.8 microseconds. It should make little difference. Other points to mention here, using some of the older hardware and software. Certainly pre-64-bit, if we'd set the file format to 32-bit, which is version 7 and before, then you'll find that you have this longest runtime. And that is the time it takes for these two values to count up to 2 billion. So we're getting an hour and 40 minutes recording time as a maximum. We have slight flavor change with 32-bit, where we can sample up to 1 terabyte or get that time limit of these two values at the 140, 1 hour 40. If we change to 64-bit, that time limit goes away, and I'm rather upset with the software people for removing it. They say it's because it's meaningless, and in fact it is. That's because the shortest time that we could now record for in a 64-bit file structure is 100,000 years. So although it looked impressive on the screen here, it was rather redundant. Okay, so resolution. Now we'll move to the mode where I set two triggers. One where I had the event trigger, the manual thumb trigger, and that sampled data from -1 second to +1 second about that event. I also listed here only channel 2. So that means that when the event channel finds a marker, an event, then only channel 2 is triggered. Any channels that are not listed here will continue to be captured continuously. And the same over here on the right, we have a keyboard channel that I'm using, and I'm sampling not from negative time, but from that keyboard marker for at least 1 second, and that's on channel 5. Now we could also force a script to run on that trigger. Okay, so a new feature there. Okay, just a quick chat message again. Can you convert a 32-bit SMR 1 terabyte to a 32-bit SMR? Well, it would make more sense going the other way, 2 gigabytes to give you more space to 1 terabyte. 32-bit 1 terabyte should still be read by any of the 32-bit programs, if that's what you mean. One of our scripts only works with 2 gigabyte file. I think we have to look more carefully at that. Perhaps you can get in touch afterwards and we'll have a look at the file. But I don't see why one would work and one would not. I'd need to know more about the script. Okay. Right, so just finishing up here, we looked briefly at the sequencer. The graphical sequencer I'd set with a sequencer resolution, a speed at which commands are executed, so in milliseconds here. The graphical editor allowing me to edit 3 outputs here, 2 digital lines and 1 analog line. For those of you that use the sequencer a lot, you might be interested to know that the DAC output here could be set, could be scaled. So we might be dealing with something like, imagine you're doing a patch clamp type experiment. So 5 volts in a picoamps may be 670. Okay, I'll get rid of picoamps there. I'll leave 0, 0 and the units picoamps. So when we edit the graphical editor, we'll see our DAC is now editable in your units, in your user units. Other sections here, A, B, and C. Okay, and the reason they've disappeared is because I've changed the scale, of course, graphical editor, and so my shapes have now become tiny because I added this ramp going from 0 to 5 volts over 0.9 of a second. I'd put a marker at the beginning. That's a digital marker, much like the box with the lit buttons, producing a code R at the moment that the ramp starts. And here I've placed this item here, which is a random delay with a minimum time of 3 seconds and up to 7 seconds. Clicking on the blue line, and I think I should open this up a little more. Clicking on the blue line, you can see that I've asked for this to be a total length of 1 second, repeating 10 times, and then where do we go? We can go to another section, or we can go to B. So B is then executed. This is a changing square wave. That also repeats 10 times. To C next, and we get a sine followed by the 3 square waves. So that's how I produce that. Play wave. We saw EMG and we saw blood pressure. We didn't really have time to go and analyze the blood pressure, but we will certainly do that in the analysis session for sure. How did I get them into this data? Well, what I did was to open a data view. Let's take channels from just the other day. Let's take this guy here. And when I've got data visible on the screen, I can go to Sample, Output Waveform, and I can set my time range, set the DAC to go to, and add to online. Now, if I can find it very quickly, I will show you something else. No, I can't see it. Right, but let's go to Cricket anyway. I can find that. Cricket. Okay, so here's some Cricket song. And again, output waveform. I think this is a reasonable size. The reason I mention that is that we need to have a decent amplitude to get some reasonable volume out of this. And we play. No, I can't hear that through this system. Never mind. Okay, I was hoping I could play that through the speakers so you could hear the actual Cricket song. But again, selecting which DAC to go to. If we had multiple channels, duplicate that and channel process, time shift just to give it a difference. And we said both channels that we want to output, sample, output waveform, selected. Okay, so we've now got 2 channels which would take up DAX 0 and 1, and we could add them to online, giving them a new key, C for cricket, for example, and add. Close. There, in the sampling configuration, we now have our cricket song holding 2.9 megabytes, 2.09 megabytes of space inside of the 41. Okay, very quickly, moving on. I would have liked in the time to have shown you some of the automation. And this may be where you want to stop on the hour, and perhaps you would then want to have a template for the name and a destination for the resulting file. Now that's not where the data is initially saved to, that's where it's finally saved to. And if I have these 2 set, save file at end of sampling, then I get a repeat count here. So 24. I'm going to get 24 1-hour recordings starting with the first named data 00. We could add to that, and that original name data, the day, month, year, etc. from this pull-out list. Okay, so some automation there. One important thing I would like to mention as well, that's output reset. So had I been using the waveform outputs, at the moment I'd stop sampling. So let's say they're sitting at +5 volts output. Well, that may be detrimental to the rest of the rig. So we can set the DACs, all 8 of them, and the digital lines to 0 or to 1 in case of the digital outputs, or another value in case of DACs, when we stop, when we start, or when the sampling configuration is added. Okay, so you're always back into a known state. The outputs don't automatically stop otherwise. They won't revert to 0 if you're actively using them when sampling stops. And finally here, the script. Here, I just wrote a very short script to output a random number between 0 and 4, and that's going to print that as a code here. The time that it puts down in text and the time that the marker is placed at is produced by max time here. So what's the maximum time in the file that we found at that moment? And this was triggered to activate every at 20 seconds and then at every other 20-second period. Okay, so a new function. This was, I think, triggered really when I was asked to output data, export data while sampling over a very long period of time. So I wrote a script to output data every hour into a MATLAB format, and it could be any other format as well. And the script just monitored time, had 60 minutes passed, yes, right, export that last hour. And it seems sensible to add that sort of capability to the automated functions here. Okay, now we've talked about an awful lot. I hope we got the gist of how we create some of these items, these channels, etc. I'm realizing now that we should have looked at where the talker channels come from. They come not from new, but the drop-down list. And the same is true for derived channels. Okay, so new just gives you a 41-based input. Okay. For the Delsys system, I added the first channel, and then I simply duplicated n times to get the accelerometer and the gyroscope information there. Now, one very final thing I promise, and that is usually the file is set to 32 data channels per file. Now, I realized that if I went on to a further analysis and creating more channels, which I would like to save back, I would soon run out. So I chose set to increase that 32 to 100 channels. And as you can see, the maximum number of channels you can actually store in the file is 2,000. As I'm sure you'll agree, it was difficult enough to see 20 odd channels on the small real estate that I have as a screen here. So you can imagine 2,000 channels is quite a challenge. Right. Oh, my microphone's rubbing, is it? Right, okay. So let's get to some of the questions then. How can you link S2 video recording to a specific channel which acquisition is controlled by trigger so that video is recorded at the same period as this particular channel will be recording, even though the other channels are recorded, for example? Right, okay. I haven't done this yet, but let's go and check how this might operate. So, let's find our S2 video program. So, under Spike2 version 10, we have Sunfix or Sun64 Fix. So these are programs which help you repair damaged, corrupted data files. The main application followed by the Spike2 video recorder, which is what we want. And then we have Try 1401. Try 1401, if we have hardware problems, 41 problems, we would run this program to test communication, amongst other things. So the Spike2 video recorder, right, where is it coming up? So settings, video capture. Okay, so these are all properties from the camera itself. Say okay to that. So configuration, video device properties, that's not going to help us either. Okay, so I'm learning here as well. So when we come to sample and we go to the mode, now this is triggered mode, then we have a trigger and we're setting a time range -1 to 1. Okay, so I'm going to need to look up the help. Let's try trigger channel, trigger connections, trigger display. No, that's not it. Okay, so where is that going to be? Video frames per second we're not saving, 0 for unset. Okay, so here we go. We could restrict this to, well, we could set the frame rate for this camera. So we're setting it at a slow rate normally. When the trigger appears, then the frame rate goes up. Okay, so this is where it is set. I'm sorry, I've never used that before, and I should try that very soon. But I'll get back to you on that, but here it is. Right, any other questions right now? Yes, you can use the Intan rather than the 1401. Why you would want to, I don't know. But yes, so if I were to separate, separate out the configuration here, okay, I'm going to put this to continuous. I'm going to throw away or rid myself of any of the waveforms here. In fact, to be on the safe side, I'm going to delete everything. The sequencer must not be used because that's 1401 based. The script can still be used. Resolution won't matter in a minute because I'm going to get rid of all of the channels here that are 1401 sourced. Okay, now here we've got a COM port, here is a user input, so that's keyboard, and here, final one, 1401. Okay, I'm going to bring across now the video, if I can find it. So let's go this 2-bit. I'll bring that across to the screen. I'll leave it there. Right, the camera. Right, and we'll switch. We'll switch the 1401 off. Okay, and we'll now press run now. Okay, waiting for the Delsys. We're ready, continue. Okay. So yes, I've got views which are dependent on those channels as well. So show hide channels. Let's switch all of those on. Draw. Okay, so now we're looking at only the Delsys channels. And of course, what I failed to do is change from triggered sampling. So one more try at that. Sampling configuration, real wave, configure, triggered start, off. Right. Waiting to start, continue, start. Okay. Oops, right, I must have done something else incorrectly there, but I would now have the 1401 switched off still, and we're only getting output from the Trinio system. Now, the sensor here seems to be operating, so I'll need to go back and probably refresh the whole of the output. And to do that, I think what I'm going to do is reset absolutely everything, and now add in the Delsys, but only after checking that I've got the talkers all correctly running. So Delsys talker, there it is, not connected. Okay, so let's try, okay, file, rescan, connection settings. Okay, I think I've set this into a spin now. I may have had 2 of these copies going. Oh, yes, I really should have reset everything beforehand. So the Trinio seems to all be working fine. I think a little bit of tidying up, perhaps another reset of the sampling here would see us through to the talker. I seem to have lost communication with Spike2, as you can see. Okay. Anyway, right, that's a bit of a failure there. I don't, well, yes, I will. I will start Spike2 up again, just to prove that it does work. Delsys talker. There we go. Right, we're not sampling at the moment. Sampling configuration, reset, new Delsys. Okay, duplicate 22 times, and if I do that, it'll give me the maximum number of channels available for the sensor. We're checking that the Delsys sensor is still active. We can see battery is good, and so we're ready to start sampling. Run now. And continue. There we go. Right. So with my sensor, okay, holding it like so. Close up look, the EMG sensors or pickups, and there's the device. Shaking it now. Control Q to optimize. on EMG as I touch on the pickups. Okay, and all that without a 14.1 operating. I did mean to talk about this as well. Not a top box, which could expand the number of channels you have, but this type of device, a Whisker Stimulator. These are the internals of it. We could drive this so that it produces higher voltage outputs through these ports to piezo filaments for stimulating whiskers. Okay. Right, I think we'll stop that. Sorry, I showed you. Perhaps I had it off the screen. So Whisker Stimulator. Driving outputs, I think up to 48 volts, controlled from the 14.1. So again, piezo filaments. Right, let's take this out of the way. Let's stop and start calling it a day. So yes, we should be recording this. Yeah, right. Should be recording this video for everybody to enjoy later. Just going through some of the other questions. Right. So, right. Ilnaz, you asked about using Intan instead of the 14.1. Yes, we've gone through that with the Delsys, but the same would be true of an Intan or combination of Intan and Delsys. Lara, could you show how to draw a shape in another channel that participants have to trace? For example, with an XY joystick instead of doing a background image. Okay, right. I understand where you're heading with this now, and maybe we wouldn't use an maybe we wouldn't use an XY view. Maybe we would. The reason I say that is that we could use something like a virtual channel. So taking our data view here, switching off all channels, hide. So I'm just going to use this as a blank canvas, and analysis, virtual channels, create new. Now I can set a sample rate here, but what I want to produce is an envelope. So a rise time of 1 second, hold time of 2, a fall time of 3. Okay, and if we go all the way to 0 time, you will see that that shape now exists here. So we could grab the data that we've produced in this waveform and pass it to an XY view. We could also go directly to the XY view and design something like a sinusoid or a square wave or ramp, multiple ramps and plateaus, as you can see here. Now, I'll take a gamble on this, and I'll see if I can open a script. I don't know whether it will work with this version, but let's try this out. Let's go XY views, see if I've got anything here. Create X1, probably not right. We may want something like force feedback. Let's have a look. Right. Let's just try this one. I apologize if it doesn't work properly. Okay, so let's try cricket script. On script. No, it's not going to work there. Okay, I can get back to you about that. We've got plenty of scripts that use sinusoids and other wave shapes that a subject is meant to trace out. We can then look at differences between the two traces as waveforms within the data view. So you can effectively superimpose the two traces there, and using a third virtual channel, you can, a virtual channel, you can then subtract one from the other and see the difference. Okay. So Lara, please get in touch afterwards. So we are recording. What is the processing delay when using derived channels versus virtual channels online? I don't know. Yes, I don't know. It's a bit of an open-ended situation there, because we may not be applying just one process or one process within the derived channels either. So you must wait for the calculation for the first to be produced before you can move on to the second. But I can certainly get back to you about that. If you're thinking about using them as triggers, as a means of firing back a trigger to the 41 to stimulate, then still you've got that 20 millisecond delay perhaps for data coming across to the computer. Then you've got the delay to do the calculations. I mean, it's all within the blink of an eye to the human, but obviously it still takes real milliseconds to be sorted, to be calculated. Okay, Jerry, is there a way to test digital inputs, outputs on the 41 when setting up a system? For example, if you want to make sure digital outputs from 41 coming into another piece of hardware and vice versa, would you use try 41? Well, you can certainly write digital outputs. That's the codes and the events, the single triggers, as it were, going out. If you wanted to look at digital markers, using mark as a sequence command to send out a pattern, or dig out and dig low, and then using a loop back cable. So if I disconnect what I have here, there's the box I've been using for marking the data. A simple ribbon cable, pin to pin, one male, one female, digital output to digital input. And that would be the simplest way to test it. So we've gone pin to pin to make it easy to crimp the ribbon cable onto it. And I'm sure if you pushed me that I could get you one of these. Okay. Right, I think that is it from me. I can't see any more questions there. Sorry, a lot of this is fairly rushed. There's an awful lot to Spike2. But hopefully it's given you, again, ideas of where things are, or what to do, and perhaps to investigate where these features are. But please come back to me offline or in the next session and ask any questions. Okay, so we'll call it quits now, and hopefully see you again next week.